Alright guys, so today we're going to start right triangle trig. I have to say trig is absolutely by far my favorite subject in all of math to teach. I absolutely love it, and I hope by the end of chapter 10 that you will, actually 10 and 11, that you'll love it just as much as I do. I'm going to very quickly go over some review with you, some just generic trig, SOHCAHTOA, sine, cosine, tangent, a couple of special right triangles that there are. If you think that you need a slower version, please make sure that you watch the review video that should also be on Google Classroom, okay? You also are going to need for this unit a graphing calculator, or just a calculator, scientific at least at that. And if you need an idea what to do with your calculator, I also attached another video that you can watch regarding your calculators, okay? But let's go through really quick. I'm gonna very briefly go through this whole page with you, and then we're gonna do some examples, some word problems, and even some of the other trig function, because these are not just it. So, all right, so let's get going. If you remember at all from geometry last year, you hopefully remembered SOHCAHTOA. Okay, SOHCAHTOA. I'm telling you, the more you say it, the more likely you're going to remember it. But remember that the sine, so the reason why we say the sine is opposite over hypotenuse, and we're just showing the relationship between the sides on the triangle depending on what the angle or the opening is, okay? So the cosine is going to be the ratio of the adjacent sides over the hypotenuse side. And then tangent is the opposite over the adjacent. And depending on which angle you're actually looking at, your opposite side is going to maybe change positions, okay? The hypotenuse will never change positions. Hypotenuse is always across from the right angle, but the opposite side will change positions. So here's a quick example. This is a right triangle. It's got the measurements 39, 36, 15, and we just found the three trig functions that go along with it. Please make sure that you're leaving everything in fraction form. Definitely reduce your fractions. All of these could have divided by 3. So you definitely want to reduce your fractions, but no decimals. Okay, I repeat, no decimals. All right, let's go look really quickly, really briefly at some special right triangles. So I don't know if you remember from geometry, there are some 30, 60, 90 triangles that have special relationships with their sides. There's a 45, 45, 90 triangle, and again, that also has a special relationship with the sides on the triangle, okay? And so what I did, I just created a nice little chart and went through and found the sine of 30 degrees based on the relationships of the 30, 60, 90 triangle. If you do the sine of 30, you do opposite over hypotenuse, so it's just 1/2. The sine of 60 degrees would be opposite over hypotenuse again, and so it would be √3 over 2. And so that's all I did with these. One of the things that you have to be careful about when you do the tangent, even when you do the sine of 45 and the cosine of 45, you can't leave your fractions in this form with radicals in the denominator. You want to make sure that you rationalize your denominator. And so that's what this little box is and what these answers look like. But hopefully you remember some of this stuff from geometry. If not, please do not worry. This entire chart right here, by the time I'm done with you, you're going to have it memorized, and you're not even going to know that you have it memorized. So that's kind of the beauty of it. But all right, so listen, let's go do a couple of examples and see what this looks like all together. All right, so we're going to do a couple of special right triangle examples, and then we're going to go through and, what happens if it's not a 30, 60, 90 triangle, or it's not a 45, 45, 90 triangle, so it's not all that special, you know what I mean? And so we're going to do a couple of examples, even a couple of word problems, and then there's one last thing to show you. I promise we'll be done. Okay? All right, so let's go do this particular triangle. So looking at this triangle, here's my angle, and from my angle, I have an opposite side, and I also have the hypotenuse labeled on my triangle. So if I actually take this and turn this around so I can look at it a little better, that might help as well. So this is the angle that we're focusing on because that's the one that's labeled. And again, I have the opposite side, and then across from the 90-degree angle, I have the hypotenuse. So the trig function that works with opposite and hypotenuse is sine, right? SOHCAHTOA. TOA. So I'm going to be doing the sine. So we're going to do the sine of 60 degrees, and we're going to set up that trig ratio. So opposite over hypotenuse, so x over 100. Okay. Using the information from the chart on the previous page, right, the sine of 60 degrees is root 3 over 2, and so I'm just going to substitute that in for the sine of 60 degrees, and that's going to equal x over 100. Just do a little bit of algebra, go get x by itself, right? You can divide by 2, and so I get that x is equal to 50 root 3, okay? A couple of things really quick. Again, please make sure you're using fractions, so I want you to actually get used to using these fractions, these rational numbers, with the radical sign, so no decimals. That is not what I want you to type into your calculator, okay? I don't want you to tell me that the sine of 60 is 0.866. I don't care. And I don't care what 50 times root 3 is. I want you to leave it in exact form, okay? So just be careful as you're going through those problems. All right, let's do another example. So according to this triangle, I have a 45, 45, 90 triangle. And on my picture, I have labeled an adjacent side, and I have labeled a hypotenuse. And so ka, right, TOA, I'm going to be doing the cosine. So I'm going to do the cosine of 45 degrees equals, let's set up this proportion, right, this ratio. So adjacent over hypotenuse, or x over 20, okay. You could right now, if you wanted to, go ahead and multiply both sides by 20 and then do your substituting. Okay, the cosine of 45 degrees from the chart previously is root 2 over 2. And of course, we're multiplying that by 20. Okay, and so we get that the side is 10 root 2. So again, be careful. Make sure that you're using these proportions, these ratios, and that you're leaving your answers in exact form. Okay, so what do you do if you don't have a 30, 60, 90 triangle, or you don't have a 45, 45, 90 triangle? Okay, so let's look at this particular problem. This triangle actually came from a word problem regarding a skateboarder and a ramp. Okay, and so here's our little skateboard guy, and we want to know what the length of the ramp is. If we know it's got a 17-degree incline, and it's only 12 inches off the ground, right? How long is that actual ramp? Okay, so we're going to go do a trig function. So let's look at our 17. We have an opposite side. We have a hypotenuse as well. And so again, opposite and hypotenuse, that's going to be the sine. So let's go get this set up. So I know that the sine of 17 degrees is equal to opposite over hypotenuse. So I'm going to put 12 over x. Now, I do want just an estimate. So 17 degrees is obviously not part of our special right triangles. So we are going to have to type that into our calculator. However, you know Hunsaker, right? And so I would prefer to do all of the algebra first and then go type everything into my calculator. It is entirely up to you if you want to do that. Or not. So I'm going to do it that way. I'm going to go ahead and do some algebra and get x by itself right now. So I'm going to multiply both sides by x. So I have x times the sine of 17, whatever this decimal is. I'm just too lazy to pick up the calculator right now. I know that equals 12. And then when I divide, I'm going to divide both sides by whatever that decimal is again for the sine of 17. Okay, so I just need to type into my calculator 12 divided by the sine of 17 degrees and see what we get. Okay, so that's exactly what I'm going to do. Remember, if you need some ideas on what to do about a graphing calculator, please make sure that you go watch that other video. Okay, so 12 divided by the sine of 17 looks like it's going to be about 41 inches. Okay, so the ramp is roughly 41 inches. All right, let's go do another word problem. This one is going to involve angles of elevation and depression. Not the depression like we're all sad because we can't see each other. None of you can see my beautiful face, but the angle of depression that has to do with angles. Okay. All right, so just very quickly, in case you forgot and need a refresher, An angle of elevation is when you are on the ground and the angle is going up. Okay, so this is an angle of elevation inside here. This is what it would look like, again, from the ground going up. Okay. An angle of depression is going to be from the horizon line and going down. So this is an angle of depression in here. Okay, so you can have an angle of elevation if it's not from the ground, which is what this next word problem is going to be. But just keep in mind that it's definitely the angle that goes, it definitely goes up. Okay? All right, let's get this guy paused. Okay, so this is the word problem that we're going to do, this geology application. So there's a park ranger. You can see him standing right here. His eye level is 5 feet above the ground. He's probably got one of those really awesome tools that will let you see what the angle of elevation is. And so he noticed when Old Faithful, the geyser, right, blew, I guess, or erupted, that when he looked into that thing, he got a 34.6 degree angle. And he wants to know, what was the height of that eruption, okay? And so this is the picture. You can read the word problem and see what it looks like. What I have done for you, though, is I've kind of moved that picture over to my notes so that we can actually do the math that goes along with it, okay? So again, we're going to find out how tall the eruption was for Old Faithful. All right, so from this information, I have an opposite and I have an adjacent. And so SOHCAHTOA, that's going to be a tangent. So I'm going to do the tangent of 34.6. We're going to set up this proportion. It's going to be opposite over adjacent, so x over 200. I'm going to do a little bit of algebra, go get x by itself. And so I know in my calculator, I need to type in 200 times the tangent of 34.6. Okay, and I'm going to get about, I think the word problem said to do to the nearest foot. So to the nearest foot, it would be 138. Okay, it's about how far the geyser blew. Now, the other thing you have to be careful about is that this little dude, right, was looking at his eye, and he was a 5 foot tall dude. And so this 138 represents this side of the triangle. It does not take into account the fact that he was holding the little thing 5 feet off the ground. And so you just need to make sure that you go and add that extra 5 feet to it. Okay, so the geyser actually erupted 143 feet. Okay, all right, we have one last thing to talk about. All right, so the last thing that we need to talk about very quickly are reciprocal trig functions. So there are actually 6 total trig functions. There's the cosecant, which is going to be the reciprocal of sine. There's the secant, which is the reciprocal of cosine. And then there's the cotangent, which is the reciprocal of the tangent. So one of the things that I always remembered is that you would think that cosecant and cosine go together, but they don't. Okay, cosecant and sine go together. So the cosecant is going to be the hypotenuse over the opposite side. They're just reciprocals of each other. Okay, secant is going to be the hypotenuse over adjacent. Cotangent is going to be adjacent over opposite. Okay, what I would like for you to do is to go work on pages 697 and do numbers 1 through 23 odds and see if you can figure out a way to turn that in. All right, let me know if you have any questions.